Hello everyone. Today we are presenting our projects, which is Security Development Lifecycle of Microsoft. SDLC stand for Software Development Lifecycle, but um, based on the present scenario that like cybersecurity is so important, Microsoft developed a security development lifecycle to help other organization to go through the security processes, which is really vital in the present scenario. And myself, my name is Deveeshree, and Lawrence, Eshwar, Melissa, we contributed to this project by studying like how Microsoft studied their SDLC and what are the key things is important for a business of it's a requirement. This slide is like, as I mentioned, that in our project, SDLC stand for Security Development Lifecycle. It's a software development process that helps developers to build more secure software, which is really vital in the present scenario due to the cyber attack, and address the security compliance requirement while reducing development cost. In Microsoft, they have 7 phases: training, requirement, design, implementation, verification, release, and response. Every phase also divided into small phases, which will be discussed each of the phases in our coming slides. Again, I'm mentioning that it's very important because in software development process in earlier, security was not that much involved. It was more development. But due to the present cyber attacks, privacy issues, it's very important to have a security development lifecycle. Now we'll focus on training. Training, like code training. This is a practice, is a prerequisite of implementation of software security development lifecycle. The foundation concept for building better software, including secure design, threat modeling, secure coding, testing, and privacy. Everybody wants a secure software where they can use for their computers and system security requirement is vital, that nobody can steal our personal information, or anybody will not able to steal our codes, development codes. So that's why the training is very important. When should this practice be implemented? Software development team members, which are in technical roles, we can say developers, testers, and program managers, must attend at least unique security training every year so that they will be update themselves into new technologies, new threat level, new signature of coding. So with this training, it would be very helpful for them to learn what are the current threats, how to address that, what are the procedures, and how they will develop their secure coding so that they can develop a better software. Next, we are coming to requirement. Establish security and privacy requirement. This is a very vital phase, which are very important because security and privacy requirements need to be standardized. It should be very strong, and this every organization, every software developers should follow that. Defining an integrated security and privacy requirement helps make it easier to identify the key milestone and deliverable, minimize disruption to plan and schedule. Microsoft addresses those requirements, and security and privacy analysis also include security experts defining minimum security privacy criteria, history of previous attacks, the past attacks. Those are the process is very much analysis. When should when should we practice this kind of implementation? Traditional software development in requirement phase and in agile development, one-time core security training. This training will actually help developers to find out that when they need it and what are the minimum security standard they need to follow while they are developing. In the requirement, there are a couple of phases. One is create quality gates or bug bar. This is a minimum acceptable level of security in every software development lifecycle. And privacy quality at the start helps a team to understand the risk associated with the security issues, identify and fix those bugs during the development so that they can address earlier and apply these standards throughout the entire project. Setting a minimum bug bar involves clearly defining the severity of the threshold of the attacks or security vulnerabilities based on the present requirement and time, where the cyber attacks is happening every day basis, and especially many times in based on the geographic location also. So it's very important that create a standard and having the information during the development process that we can address it early. When should we practice? As we mentioned that it can be practiced in requirement phase, and in agile development it's one time. As in our project we are studying of traditional software development to agile development phases. Microsoft actually divided when can we implement based on the business scale and size. The third sub-phase of the requirement is perform security and privacy risk assessment. Privacy risk assessment and security risk assessment is important because in software designing phase on cost and regulatory basis, requirement helps a team to identify which proportion of a project will require threat modeling and security design reviews before to release. Before release of software, if the security development team or software development team together are able to find out the risk, then it will be easier to address it. As we mentioned earlier that when for the traditional software development, it can be used in at requirement phase. In agile development, it can be used at one time. Now we are switching to design. As we know that software development lifecycle, the traditional software development lifecycle design plays a vital role. If we do not have a software design, it's very difficult to imagine what is the purpose of a software. So in the same way, in security development lifecycle, they have design phase. The first phase is establish the design requirement. It's very important because here we are addressing the security and privacy concerns early, helps to minimize the risk of software. What the software while the developers developing a software, what can be the risk, and reduce the project expenses. It also cost point of view is very important. Validating all design specification against a functional specification involves accurate, complete specification, including cryptography design requirement, which is a very vital for developers, and it actually helpful for us to develop a secure software. When attackers trying to attack on a software, it's difficult to break it. It's very difficult to steal information when it is encoded or cryptographic design is involved. When should this practice should be implemented? In traditional software development process, the design phase. In agile development, it can be implemented one time. We are still in the design phase and continuing. The next phase is perform attacks, surface analysis reduction. Perform attack surface means every organization can have a security team who actually perform internal attack to address that whether the software they're designing are measuring the security threats or not. It's very important because it's a kind of internal audit that you are checking your software is capable of to address the present security signatures or the present attacks and provide the solution. Addressing security and privacy concern also helps to minimize the risk of the schedule disruption and reduce the project expense. Validating all design specification against the functional specification involves accurate and complete design specification. It can be involved or applied in design phase in traditional software system, and in the agile development it can be bucket and planning process. Next one is using threat modeling. It's very important to use of threat modeling. When you are applying a structured approach to the threat scenario during design helps the team more effectively and less expensively identify the security vulnerabilities. We can compare between a software who doesn't address security development lifecycle and a software who are actually addressing security in each and every phase of a software. Which software can be more secure? I'm pretty sure a software which is addressing security development lifecycle in each and every phase, they will be more secure and more up to date to address the cyber attack. And it will very important to determine the risk of the threats and and establish the appropriate mitigation. When should we practice? As we mentioned that in traditional software, we can mention or we can practice it in design phase, and in agile development, it's sprint. Next, we are discussing about implementation. As in security development lifecycle, implementation is one of the phase. The first subphase is use approved tools. Publishing a list of approved tools and associated security check is very important. It's like a checkup. We actually need security check every timely manner. It can be yearly check, it can be 6 months check, it can be weekly check, but it will be categorized. It also helps us automate the cost very low. Keeping the list regularly updated means the latest tool version are used and allows inclusion of new security analysis. This can be an example when we always get a notification from our iPhone or in our Windows devices to get an update. It means that they are newly updating the technology based on the current requirement. If we are not going to update, it means we are vulnerable and cyber attacks can be performed. When can it be implemented? It can be implemented in implementation phase, and in agile development, it can be implemented every sprint. In implementation, the next phase is deprecate unsafe function. It means that analysis of project functions and API and banning those determined to be unsafe helps reduce potential security risk. After every security check, if there will be an update which actually increases the security check, we actually deprecate the unsafe functions, or we can actually go ahead and remove it if we'll find that there is a security threat. Specific actions include header files, newer compilers, or code scanning tools to check code for functions on banning list. It means it's kind of blocking when there will be updates. If there are some files within the system during the check we found that can be vulnerable to the system or software, then we can actually replace it or remove it or put it on a block list that it won't be threatening in future. Traditional software development can be implemented in implementation phase, and in agile development it will be every sprint. Implementation. The last part is perform static analysis. Why it is important? It's important to analyze the source code. When we develop a software, it's very important for us to review the codes and update it based on the timely manner, based on the updated technology. That's why analysis is a vital part. Analysis the source code prior to the completion offers a scalable method of security code review and helps to ensure that secure coding policies are being followed. Coding policies is always a standard, needs to be followed to be more secure while we are using any software. It can be implemented in implementation phase. In agile development, it can be implemented in every sprint. Next, we are coming to verification. Why verification is important? In software development lifecycle, verification is important to understand why the software is important, the purpose of the software, and in security development lifecycle, when we are following security development lifecycle, verification is important based on the present updated technology, the cyber attacks, and why things are happening and how to address it. Without verification, it's very difficult to understand where is the error, in what phase, and how to address it. The first phase is perform dynamic analysis. Performing runtime verification of our software checks functionality using tools that monitors application behavior for memory corruption, user privilege issues, and other critical issues. So to address that, verification phase is really important. And while developers are developing traditional software development, they can use verification phase, and in agile development, it can be added in bucket verification. The next phase within the verification is perform fudge testing. It induces the program failures by deliberately introducing malformed and random data to an application helps to reveal potential security issues prior to release while requiring modest resource investment. It is really important because it actually runs automatically within the software to try to find out where there is a vulnerability and address before the software release. It is important because before software release, if we can address any kind of vulnerabilities, then it will not impact the customers who are using. So we can stop before it is released and user will be benefited. It can be applied in verification phase during the traditional software development, and in agile development it can be applied in bucket verification. The last one within the verification phase is conduct attack surface review. Surface review is very important because it depends on the code completion, and it helps to ensure that any design or implementation changes to an application or system have been taken into account, that any new attack vectors created as a result of changes that had been reviewed and migrated, including threat modeling. Conduct attack surface review helps us to understand the attacks has been performed, what are the results, how our software is capable to address the new attacks, and is it our code is capable of addressing new attacks or not. It's basically the review process analyzing the security threat level of an attack. It can be used in verification phase in traditional software development, and in agile development it can be under bucket verification. Now, after a software development lifecycle gone through every part of security development lifecycle, it's time for release. There are the things what we should, or a software engineer or people who are within the software development team, this development team, designing security team, what should we do? They can create an incident response plan. It means if things happen which is go beyond the hand, what are the plans can be taken if the attacks are happening. They can prepare an incident response plan, which is very crucial for helping address new threats. It also helpful for users who do not have idea that what is like cyber attacks, how to do precaution. In that time when cyber attacks are happening, they can address with this plan. It includes also identifying the appropriate security emergency contracts and establishing the security servicing plan for code inherited from other groups within an organization. It also includes where to contact and how to contact, what are the processes, and third-party code. When this phase can be implemented in traditional software development, it will be in release phase. In agile, it can be implemented one time. Conduct final security review. After have gone through all the processes in security development lifecycle, there should be an important phase. It's called final security review. It is very vital that we check all the time finally that every phase of software is working fine or not. In our real life also, whenever we are trying to develop a software, write some codes, we check again and again and again. So that's why every phase, it's very important to reviewing process. This process, in the final security review process, we deliberately review all the security activities which are performed, helps to ensure software release readiness. The final security review, which is FSR, usually include examining the threat model, tools output, perform against the quality gates, bug bugs defined during the requirement phase. FSR includes three outcomes, which is passed FSR, passed FSR with exception, passed FSR with escalation. In this security phase, they actually find out that what are the exception can be done, or we need to review the security code, which phases we need to take care of. This is the final review process. In traditional software development process, it can be used in release phase, and in agile development process, it can be in every sprint. Certify, release, and archives. Why it is important? Because after going through all the processes and final review, now the software is ready with the security development lifecycle addressing. Certifying software prior to a release helps ensure security and privacy requirement. So when a customer is using our software or any software, they will be released that their privacy information, their private information is protected. That's personal identify information, which is PII. Achieving all pertinent data is essential for performing post-release servicing tasks and helps lower longer-term cost, because security development lifecycle can be applied to any scale business. So it can be a large organization like Microsoft, it can be a small organization. So any security development software, if a developer is building, it should be cost effective in longer term. Archiving should include all specification, source code, binaries, private symbols, threat symbols, documentation, emergency response plan, and license servicing terms for any third party. It is very important because it will help the users to address the threat or to understand that how software works. It can be implemented in release phase during the traditional software development method, or it can also be implemented in every sprint. Finally, it will be the executive incident response plan. This is actually referred as being able to implement incident response plan to release phase is essential to help protect customers from software security and privacy vulnerabilities that emerge eventually. Delivering security updates and authoritative security guidance. The Microsoft Security Response Center is a global team working around the clock to identify, monitor, resolve security and incident and Microsoft software security vulnerabilities. So if a customer is finding any security vulnerabilities within any software, they can report it. They can find out the solution by contacting Microsoft Security Response Center, where they work to identify and monitor with every software a user are using, and every device is connected to Microsoft softwares. So this is the summary and the diagram of like how many phases. So there are 7 phases. As we can just lastly we can just review that the important main 7 phases are training, requirement, design, implementation, verification, release, and response. Within training is core security training. Within requirement, there are 3 important sub phases. Those are establish security requirement, create quality gates and bug bars, perform security and privacy risk assessment. In the third phase, design, that also have 3 sub phase. First is establish design requirements, perform attack surface analysis and reduction, use threat modeling. In the implementation phase, they use approved tools, deprecate unsafe functions, perform static analysis. In the verification phase, perform dynamic analysis, perform fudge testing, conduct attack surface review are very important. After going through training, requirement, design, implementation, and verification, when a software team is coming to an end, which is a release phase, They create an incident response plan for the user or everyone who are using software, their software. They conduct a final security review based on the updated attacks, and they certify and release the archives. The response is the final phase, which is execute incident response plan effectively. In this project, we actually analyzed that how a security development lifecycle will be vital for traditional software and agile both, and it is very important to address it in the present environment when we see daily basis that cyber attacks are happening and our personal information are stolen and sold in a dark world where we have no idea that what they are going to do with our personal information. It is a huge risk, so it's very, very vital and every organization must address. So this is our reference slide where actually we use the sources from the Microsoft website. There are other sources which will be in detail elaborated in our report. Thank you so much for taking time to listening to us, and we have contributed based on the present requirement in cybersecurity, where security development lifecycle is very important. In software development lifecycle, we really appreciate your time and we look forward to have your feedback on our project. Thank you so much.